All right, I think we got it figured out. Here we go. We're doing binary search trees today. This is module, I don't know, 6. Let's go back a page. This has got some interesting stuff. If you check it out, the module 6 reading, there's like lots of ideas on how to do these search trees. We're gonna implement this today. Fuck off. We're gonna implement this today, and it's like hard coded. Then look on how to make it a function where we can add them. These will all be treated as nodes. But it's got a lot. Look at all these topics you can like get ideas from. Don't copy them. Just look at it for ideas. Otherwise, you're not learning anything, right? You also have the textbook we have. Where do I have it? That's in Discord. Chapter 16 is tree implementations. So what's a tree? Let's go back to our module. So a binary tree is a tree that has 2 branches coming out of any particular spot, and only 2. The one that's at the top is called the root or the parent. They're going to be nodes. We're going to use our node thing. We're going to build on our nodes. This is very much like a linked list, but like not in order. A tree can be in any order. A search tree follows a very particular order. You will notice as the arrow that goes to the left goes lower, and the one to the right goes higher. And this follows for any branch. 3, left is lower, right is higher. 6, left is lower, right is higher. We follow the 8, the 10, down to 14, down to the 13. 13's down here. And it follows this stuff right here. You can actually copy and paste it. I've done that. I've even modified it a little bit before I got started. Oh, this is, that's Ainsley's madness. We'll just turn that off right now. She's not yelling at me yet. I'm surprised. All right. So it's a node. We're going to have a data value, and just like the tree shows, it's going to go left and it's going to go right. I'm going to write down that search tree real quick. That way we have it on paper and I'm not flicking back and forth between them. Let's come over here and look at it. It is a one-directional list. I implemented this as a doubly linked tree. I tell you, it's a pain in the ass. It makes some things easier, but dealing with that previous node when you're trying to insert and delete nodes is a go fuck yourself in the head with a fucking metal screwdriver thing. It took me like fucking 16 hours to figure out how to do the insert and delete methods. Using a doubly linked format when I did this. That was a year ago. If I were to do it again, I would do a different approach. I would just follow maybe what the book is going with. The book has lots of ideas on how to retrieve an entry, enter an entry, stuff like that. It's worth checking out. It doesn't say, it gives most of the code, so you can get it for ideas. But it doesn't say everything. Like it'll say if n was a left child, make c the left child. It doesn't fill in the work for you. But it'll give you a guideline, like ideas of how to do some of the stuff when we're going through it for everything we've done in here. So it's got data. Apparently we're going to hold data value and integer. We got left node, right node. Find depth shows how deep down you are on the tree. We'll take a look at that later. Void report reports the tree out. Then we've got a class, the binary search tree, which is definitely there. The binary search tree is in that order that I was showing you. It always, you can follow the left one down. It's always getting lower and lower and lower. Whenever you take a right, it goes a little bit higher. But a binary tree can be in any order whatsoever. The only node we need is root. It's public right now, part of one of your assignments later on. Make it private so that you implement this as a good, nice project. Gave some ideas of things that we can get done. We'll do some of them in here. Let's see. And we'll just start off with the one we got. Let's see. What do I want to start here? Well, let's start off making a tree. And my tree has a root. So I got two things right now, you can see them. Root and depth. And my tree.root, initially we should set it to an old PTR. That should be the first thing it does. Maybe this should be a constructor later on. We'll put this in a constructor later. We can give it a value. Oh no, I gotta make it a new node first. Make it a new node. And now my tree.root got other things, data, left and right. We're gonna do data. And the first one we had was an 8. And we will set the left to null. And we'll set right to null. And we should have a myTree.root.report. That was a display function. Just see if I set it up decently. All right, showed an 8 there. We've got the 8 in there. Okay, so we started off, we put in the root here as a null pointer. This is binary search trees. And this will be our demo tree. We put that in as the root. And these are currently, right now, we're just looking at null. They're pointed at X's. Okay, so we need to go through and hit the rest of these. And so kind of like we did with the linked list, I could do myTree.root.left.left. That's a pain in the ass. We should probably come up with a temporary, do like a node pointer. So maybe let's put in a node temp. And maybe here, we'll change this. We'll do temp equals mytree.root. And now I'm gonna be able to make all this easier and not have to type all that shit out. Avoid typing all that lame shit out every time. Just work with temp. Nope, don't even need the root. Get that done now, because that was already annoying. Already, didn't take long. And we'll put it after it as well. All right, make sure I didn't fuck anything up. Apparently I did. What did I fuck up? Uninitialize local tree my variable. Maybe I gotta do my tree equals new node first. No, let's do this. There we go. Okay, that's working. Okay, so like your first assignment is actually to go through and hard code this shit. And by hard code, I mean type the shit out. So we're at 8 and we want to go to the 3 next. We're looking at, not that. We want to go to the 3 next. So we need to go temp equals temp.left. And we'll make this a new node. And we'll do temp data equals 3. Temp.left is null. And temp.right is null. Make sure that prints out. It did not, just printed the 3. Oh, I had it temp reporting temp. I wanted to report my tree.root.report. How far did you make it before you got mad? Why isn't it working? Okay, let's see what we got. Oh. Let's do a report right there after the first one. How far did you get? You didn't even do that one, okay.
Can't you just do temp report? I don't think that changed anything, but.
Yeah, when I had temp report, I was only doing the last one though. Like if I come down here and do temp report down here. Now it should do it, but it's only showing one at a time. That's not how this is supposed to work.
Oh, it's supposed to, oh, temp report's supposed to say all the values?
Let's make my tree dot root, maybe temp's just pointing to the null pointer. That's the problem here. Temp is pointing to a null pointer. Or my tree dot root's pointing to a null pointer. So let me go back here and put my tree. And we gotta do the my tree dot root equals a new node first. Get rid of that line. Okay, that should work. It does 8, then it does 8. It didn't do all of it. Why not? Maybe I need to do this first. We're gonna say temp equals, or temp dot left equals new node. Because I'm jumping to a null pointer again. I'm making the same mistake I had up top. Now I'm jumping to an actual node. There we go. All right, now that we got the order figured out, the next one down was, we gotta make a new node again. Part of it's figuring out what you gotta do here. That's what the point in the whole hard coding is. And now we set temp.data equals, we had a 1 next along the left. Say temp.left equals null. Temp.right equals null. And now if I do another, I can do a report between each of them, make sure it's building correctly. 838138, okay. We've got three branches down. We've got a 3-element tree, but it's really just looking like a linked list right now. So I've gone through and I've done 8 and I've done 3 and I've done 1. And now this is the spot where I'm kind of like, I wish I had a previous pointer like we did with the doubly linked list, because it makes it easier to go back. Instead, I'm gonna go to 6. I'm gonna have to go all the way back up to the root and start at the root again to hard code this, which is fine. So we're down here.
Maybe you screen shared the wrong screen.
What?
It's just the Windows. It's
Okay. Oh, wrong computer, laptop. So I need temp to equal my tree.root again. And that takes me to the 8, and I want to go to the 3, so I'll go left there. And that should put me at 3. And now I want a new right node. So temp.right equals a new node. And now we jump to temp, right? Temp dot data equals 6. Temp dot left equals null. Temp dot right equals null. All right, so see, it put 6, right now the report is printing them out in order. So it put the 6, prints the tree out in order. Okay, so I'm at the 6. If I want to do the 7, I don't need to go back to root again yet. I can just say temp.right equals new node. That should, and then jump to it, and that should give me a 7 there. So we jump back to the root to put in 6, jump back to root, transfer to 3 to put in the 6. Oh shit, we're gonna have to do it again for the 4. So I got the 6 and the 7 in, but I don't have the 4 in yet. So I'm gonna have to jump back.
You can stay at 6, right, and then just say.
Well, one of them I'm gonna have to jump back. I do the 4, and then I still gotta jump back for the 7, or I can do the 7 and I gotta jump back for the 4. One of these is gonna have to happen.
But you can also stay at 6, right, and then just do everything from 6.
I could, but that's, I could, but like big picture, that's not really what we wanna do.
Gotcha. Well,
Because you can't like,
Automatic.
that's not extensible. That's a one-time solution.
Yeah.
We want something that's extensible. So yeah, I could definitely do left, right, till we get there. This got me to the 3, and I need to go right again to get to the 6. Okay, that takes me to the 6. Oh wait, hold on. That's not where I wanted to go. It's right, motherfucker, right there. That's where I'm doing it. I want to go right there. So my tree root takes me to the 8, then I go left, takes me to the 3, then I go right, it takes me to the 6, and now I can drop in, I need to do left here. So the left. I like being able to highlight over shit and then just fucking type. And here I have to fucking delete. How do I turn that shit off? Like, how can I highlight it and just, like, I've got left hit highlight here. Oh, it fucking work now.
Did you have insert crest?
Yeah.
I didn't change anything. This thing's just trying to piss me off. That needs to be a 4 though. There we go. We get the top half, the left half of the tree. So what are we gonna do? We gotta jump back to the root. Now we're working on the right side. So I just want to jump back to the root. And I don't want to do left, I want to go right here, temp right. And then jump to temp right. See, it did it right there. Righty. This took us to a 10. Is it a 10? It's like a 10. It's a 10. All right. And I don't have to ever jump back to the root because this is all a chain right now, isn't it? What happened? So temp right is a new node. I want to make this a 14. And then I want to copy and paste that. And this time I want to go left because 13 is less than 14. So we're going to go left. All right, so we've got the hard-coded thing up. Now let's look and see if we can do this another way. Well, actually, I want to go take a look at the report real quick. Because right now, it's kind of interesting. It says if left, then go left and report. So it's a recursive call. Cout data. So let's do a little trace on this. Let me write down what the code is. Because knowing how this works can help you figure out how to change it. Like if you want to print backwards and stuff like that. If left, go left, report. Cout data. And if right, go right, report. Okay. So let's take a look at entering this. With the tree we have right now, we've got the full tree being built. It's already coded up. So we start off and we do my tree report, or my tree root report, and it starts at the 8. So it starts at the 8. And we have the if left, go left, report, go left and report. And we get to that line and there is a left. So this line triggers. And we got another box here. We've got if left. And this is at the 3. If left, go left and report. And we have a left here, so it goes left again. If left, go left, report. This is at the 1, and there is no left. So that line's done. Let me make a little output box. Like what is it doing with the screen? So now the next line of the code is cout the data. And the data here is the 1. So it's going to print 1. And then it says if right, go right. And 1 does not have a right. So that line ends. This pops off the stack, this part of the code's done, and it returns down here to go to the next line. The next line here is see out the data. So a 3 gets printed. That left line was done, we're seeing out the data. And now it says go right, if right, go right. And report. And we do have a right. So this will take us up to another box here. This box here is the 6. And we got if left, go left. We do have a left. It is the 4. If left fails, so it does a see out of the data. So 4 goes to the screen. And then it checks if right. That fails, and it returns back to the 6. And we can pop that one off the stack. We're at 6, the go left is done, we see out data here. And then we go right. If we can, and we can, there's a 7. That takes us up here. On the 7, the if left fails. So the see out the data line triggers. It prints the 7. That line ends. It does the if right, go right bit. That fails. That version of the code is done. It pops off the stack. It returns back to go right. Go right is done now. Now this pops off the stack. And this comes back down to here. And that was our go right here. This pops off the stack. And we're finally to 8, back down to our root case where we go, the left line is done. Let me hit autofocus. It doesn't look all that clear, does it? That's a little bit better. It says see out the data. We do the 8. That's done, and it says go right. And now we can go through and do 10, 14, 13. But it's following the same thing. If you draw out this thing, the recursive trace, you can kind of see what's happening. So this is actually printing it in order. So maybe let's call this, let's change the name of this node report to report in order. I go out and rename it up top. Oh, I need to rename it everywhere, don't I? So Control F. Report. Report in order. Why do you like that? Did it not do it somewhere? And effort, it's got void up here. What the fuck? I changed it to report in order. Okay. It's just fucking moody about some shit. Why? Class node has no, yes it does, we fixed that. Ah, there we go, just click save, that fixes it. Okay, so check this out. What if we swap these? Let's make another one. Deno. I'm gonna call it Deno for right now, and we're gonna put if right first. And we will move that to after the data. And I need this up here in node. Okay, I got node report, Deno. Let's come down and see what my tree.root.deno does. My tree.root.report Deno. Illegally qualified name on line 16. Oh. I don't need to scope it up there. So it looks like it wound down the left tree or the right tree, did 10, then it went left there. Oh, I know why, because it's not recursive there. It's redoing recursive on the wrong one. It switched to the other one. I need to do this one as report Deno. I'm like, I know what it's supposed to do. The Deno was for theatrics. Now look at that, it printed out backwards. So if we did a recursive trace, we would see that it was doing the same thing that we did on our paper. It's doing it backwards, so maybe we should change Deno to report backwards. And that way we've got a report backwards and forwards function. Did it take effect up there? Why has it got? Okay. Okay, name change is fixed. All right. Okay, so pain in the ass, right? we don't wanna do this hard coding thing, so I'm gonna gray all that shit out. Well, before I gray it out, maybe we should look at, let me copy some of it and just put it somewhere else. I'll put it up here above the main. I'm gonna use that as a workspace for a second. I'm gonna comment all that good stuff. Too far. I guess I didn't need to comment out this, well, yeah. Maybe we should make we got this class, maybe we should make a constructor. And we can have a default one, and we can have one that takes in a value. For the default one, maybe we'll say int value equals 0. Okay. So come down below. There's a lot of fucking code there. I think this is where we started implementing our functions. Do this a couple times. All right, so we need to scope it. And here we need to say root. We're implementing the start of the code. So what did we implement up here? Let's kind of copy that and put that in there and edit what we need. So root equals new node. And we don't have a left. Root.data. We'll set that to 0. And that's got to say root as well.
I think you need a scope,
I need what?
scope resolution.
You're right. I do need a scope resolution only. What is it tripping out on? And I meant to do that earlier and I got fucking distracted by something. And then come down here and put it on that one. Here, I think this is gonna be the same thing in here. But root data equals value. All right, let me maybe not put that in there, just leave it empty. Let's comment out that real quick. Let me uncomment this shit so I can use it to test. Testing a constructor here. So if I did that, I don't need this line anymore. I don't need that line anymore. What is wrong with this?
I'm thinking of the parentheses for the default constructor in your line 42. Because it thinks you're doing a function call.
Oh, you're right. How should I fix that? Just do my tree?
Yeah, if you want to do the default constructor.
Yeah, that's what I want to do. I do the default. Okay, and just to make sure the default worked, before I change the data, we'll do a printout there. Excellent, so it's got the 0. And we know that one works, we're not gonna worry about it anymore. Now we'll just start this at 8. And I can comment out that part because it's already done. We should get the same thing. Bam. All right, so we got a nice little constructor set up. Okay, add node. Add node. So what we want to do first is add that left shit. So let's do it up here in the binary search tree at first. That way it'll just make it a little bit easier. It's not going to have a return. We're just adding a node. And we want to send it in an integer value. This worked a lot better when we have a pointer to start off with. So let's just make a pointer right away. Call it root. And we're going to say we're starting at 8 here. Oh, well, maybe we should say, if we want to make add node and be able to use add node in the constructor, maybe we should make sure root isn't a null pointer first. Root equals a null pointer. Then I got to do exactly what I did in binary search tree. In fact, if I cut that and just say add node, nope, that's not gonna work. Cut that one. Do add node here. It's gonna say it doesn't work yet because we don't have it in yet. But we come up here and we drop this bad boy right in here.
Wait, wouldn't it be the other one because we want the value to be inside?
What?
Because this add node is drawing from the original, right? The binary tree without the integer value.
I went out and changed it. So that this one is still doing a 0.
Oh, I see.
This one's doing that one right there. So I don't want to do add node 8. I want to do add node value. That was dumb. That's what I want to put there. Okay, so we got that up there. I'm just gonna run it, see if adding that, oh, I didn't actually use add node in the program, did I? Yeah, I did, because I used add node is in my trees, in the constructor. So that did work. All right, so now if it's not the root, what do we do? Well, we need to compare the value, right? The value coming in, we need to see how the value coming in compares with temp.data. Let's just do the first level. We'll look at doing it, going down through all the branches, once we have an add left and an add right down. So value is less than temp.data. If the value is less than it, then we want to build a left tree, right? So this would be build left. So I need to say temp.left equals new node. I think that we have this down here. I'm gonna go copy that shit. Let's work smarter, not harder here. And uncomment it. But we want to change temp.data here to value. And then we can say else and uncomment that. Mother. And this needs to be temp.right. And notice we're doing this data value null pointer thing 3 times. We're doing it here, we're doing it on the left, and we actually did it up here. So maybe we can just take this and move this outside and put the populate in there. And here we're just using it to navigate to the right spot. So let me go test this. This is an add node, we've got it. So if the data coming in is less, it goes left. If the data coming in, it goes right. We will do temp.add node. Why isn't, oh. Temp is mytree.root. Why can't I do add node there?
So that's in binary search tree, right?
Hmm?
So,
Yeah, it's above root, isn't it?
well, you have to do it from my tree, not temp.
Did you say temp equals my tree? Nope. Whoop. That's what I had. I'm just stopping to think about it. It's in binary, and if I'm using temp, I'm using temp.root, which means I'm already in this. The root doesn't have access to that, does it? Yeah, I need to. Huh. Okay. We will try doing mytree.add. We're gonna add the 3, and we're gonna try doing mytree.add the 10. I guess I don't need temp in here right now. I've been trying to work with temp, and I don't know that I need it anymore. Okay, that didn't print out everything. Just printed out the 3. So whatever I'm doing, it's overwriting. Why is it overwriting?
I think you have to like, sort, you have to iterate through until you get to like the null pointer, and then you can add those things, otherwise.
That's what this part is. This is iterating.
No, but that only iterates one, right? You have to do a while until it reaches.
I'm only doing the top row. I should only have to iterate once.
Oh, I see. Oh, you're only testing. Oh, wait, yeah.
So if root equals null pointer, it's not null pointer. So let's do. This is how you find errors and shit. So if root equals null, so this is when it installed the 8. And then it did set C triggered because I sent in C shouldn't have triggered. C was go right. Do I have the way I'm listing it wrong? So temp data is 8, the value I sent in is 3, it should have gone left. It should have done 8, then D right away. If root equals null pointer. C out A, root equals a new node. And then, oh! Yeah. That's the problem, these all say root.
No.
I'm coming out that fucking C out bullshit. I think that was it right there. Yeah. Nope. So we'll put it back in.
I think it's fine, but can you just call up for a second? I think you need,
What am I missing?
in the very first if statement, the if root equals null pointer, I think in there you need to do the same stuff you're doing with temp, but you need to do with root. Like you need to do root data equals value, root left equals 1.0.
But I do that down here,
But that's only for temp, it's not.
but I've assigned temp to root.
Would it be an else if? Because
Oh, yeah,
then you're assigning left instead of the root.
because it's checking for the if right after, it should be the else if.
You're right, the way I've got it going.
Or, I thought it was above, like, for the middle one where it says if value is less than temp data, line 37.
Right,
Shouldn't there be an else if right there? Because you don't want, once you already have that, you don't want the other thing.
well, no value's been assigned, nothing's been assigned to the value yet, right here. All I've done is made a new node, so there's no value when the root is empty. All we've done is made a new node and we've set temp to the new node.
So,
Yeah, you're right, because it's got nothing to compare to.
yeah. You'd have to put either like an or like an and statement, or you just like root dot.
I think we do need both here. Because it's trying to do a comparison that's. So let's put this above.
But temp, no, it's not. Now temp is just nothing, right? Or no, yeah, because temp is, no, yeah, because if temp is null pointer at the very beginning, then that could be a problem.
I think that line should be where it was.
Where was, take out the else? So nothing else. Put this back where it was.
I think you need a new else if and then put the entirety of the code within it, no? Like, and then including the node.
For what? For what, why?
Because you need something to compare it to still, to see if it's a null pointer or not, like the root. So you would have to
That's,
do like a new else if, no? And then you would keep the.
maybe I should do if root is a null pointer, then return right here.
Oh, yeah.
Right? That would break it out of the add node.
Maybe.
Why doesn't it like this?
Root data,
Oh, yeah.
root arrow data.
My test is like my fucking ChatGPT. Right?
That doesn't need the if.
Yeah, it doesn't. Oh, that's why I wanted parentheses too. All right, I don't think I'm getting rid of that. I'm confident that's right. I'm so confident I'm getting rid of my fucking test, my error checking. There we go. Yay! All right, so now we've got an add node left and we've got an add node right. That just gets us to the first level. Now, when I took this class and I was learning how to do this, watching Mr. Redden try to do this part was fucking torturous. It was fucking torturous because he did not want to make another node pointer. But if we make another node pointer, we can do some stuff like this. We want to be able to iterate. So like, let's see where we're at right now. Right now, we have the 8, and we have the 3, and we have the 10. And we want to say when we hit add node, it goes and searches and takes me to the correct branch. So let's say I'm going to do add 4 next. So add 4 needs to go, okay, follow the left path and then realize where to go from here. Once it gets to here, it will figure out where to go. Because our code said like the value less than temp data and value greater than temp data. If we can get to 3, if we can navigate to 3, we're good. Not 4, we'll do 6 next. 6 is next. Not 4. 4 is not off, it's 3. So what we've got right now is we've started off and temp and current are both pointing right here. And what I'm going to want to do is go, okay, do like a check and go, okay, is my next spot a null pointer? I need to go lower, like 6 needs to go this way. So I need to check if it's a null pointer, and if it's not a null pointer, I need to jump to it. So jump. Current jumps to here. 3's pointing up there. And then it does the check again. And I don't want to leave temp up there because I can always get back to that with root. We'll bring temp down here after current gets assigned. And then we'll make current be the new node. But we can't jump to it. We gotta leave temp intact. Because we gotta know where to stop. Let's see if I can do this a little bit better. So while current does not equal null pointer, we're gonna, temp will jump to be the current pointer. And then we go if value is less than temp data. We want current to jump to current left. Okay, so now if current is a null pointer, it means, so this is what this means. If current is the null pointer after jumping, temp is where we wanted to stop. And then else current equals current right. So if the current is a null pointer after jumping, again, temp is where we want to stop. So like right now, we go through the cycle, which start at 8. 8 is not a null pointer, so, and we're trying to put in 6. So it goes 6 is less than 8. 6 is less than 8. We're going to jump to the next branch down the 8. 8 is going to take us to the 3. We get through the while loop, and it goes current is not a null pointer. It's pointing to the 3. So we go through it again. 4 is now greater than 3, so it's going to go current equals current right, which is a null pointer now, because 3 had a null pointer off the right. And now when it comes up here, it's going to go, nope, I don't need to do this loop anymore. I'm done. Current is stuck at the null pointer, but temp is stuck at the pointer right before the null pointer. So it's pointing at the node before it, it's still at the 3. So it jumped from 8 to 3. And this one, I'm gonna put this line up here. This one jumped to 3. And then here, jumped to null. So temp is stuck at the pointer to 3, current is now stuck to null. And now we are at the node for 3 and it should print. Not print, but it should be where we want. I lost my bracket. Now we're at bracket 3, now it does the check again to go, do I add left or right here? Does that make sense? Let's give it a try. It did, it worked. It's in order. So maybe showing it pictorially might make it a little clearer. We had 8, 3, 10. So the code is while current does not equal the null pointer, temp equals current. And then if value is less than temp data, then current is going, the value is less than the current value, so we want the current to follow the current to go left. And then we say else, current equals current right. So that's the code. So when we do add node 6, they both start off, temp and current both start off pointing here. And current is not null pointer, so they're still pointing at 8, and then goes, is the value coming in less than the temp data? 6 is less than 8, so current jumps to current left. And the while loop, that cycle of the while loop ends. The next cycle of the while loop starts. Current is not a null pointer. So it says, okay, temp, come on down. You can come join us. It's like the poison tester. And then we go, okay, is 6 less than 3? No. So we skip the if part, we go to the else. And current jumps to the right. These are both X's right now because they're null pointers. And current comes down and points at this. And right now temp is pointing at 3 and current is pointing at this. The while loop ends and it comes back up and says, is current null pointer? Yes, it is null pointer. So stop the loop. We've stopped the loop at temp 3. Will it work when we do add node 10? Oh, not 10, 14 was next on the right side. or even better, let's dive down the 6th branch. That makes this a 6. And we've got null pointers here now. So what was next after the 6? We want to add a 4. Let's try adding the 4 now. Add node 4. Now we're going a couple deep. So let's figure out how this is going. We'll do it on the left. On the right side here, temp and current are both pointing at 8 at first. Current is not a null pointer, so it goes to the value check. 4 is less than 8, so current equals current left. That pointer goes away, current comes down there. And we go to the loop again. Current is not a null pointer, so temp joins current at 3. And then it goes, okay, is 4 greater than 3? Yes, it is. Well, it says is 4 less than 3? No, it skips the else thing, or the if thing, goes to the else thing. Current jumps to 6 now. So the second loop of the while loop ends. Current is at 6, temp is at 3. Current is still not a null pointer, so 3 joins temp at 6. And we check 4. 4 is less than 6. So current jumps over here. That ends the loop. Current is now null. And temp is pointing to 6. The while loop ends, temp is 6, and it adds node, it should add node 4. It should do the next check, which was do the left right check thing. It should be able to put the 4 in here now. So that's how the while loop is breaking down. If you don't do a second pointer, it's like you have to maybe do a counter, or I don't know how you would track it, because you got to be able to go back. You don't, or maybe we could do not while current, because you can't say is current next a null pointer, because there's 2 nexts. There's a left next or a right next.
Do something like if current, or not current, but if right is, if value is less than whatever this is, check left, and then if left is null pointer, then add new node. And then the whole null pointer right.
I think you could maybe do it, but the navigate, because you gotta be able to, it's gotta be able to loop back to the top each time. And it's gotta check for different forks it's gotta check for 4 different forks, at least 4. So the gymnastics of trying to do that and keep 1 pointer without going able to go backwards. If you have previous or node parent, it's easy here. You just navigate through till you get to it's a null pointer, and then you go temp equals parent. But I'm telling you, I was all gung ho, that's what I did, and it worked great for adding nodes. Fucking adding nodes was fine. Inserting nodes into the middle is a bitch. Because we might have, I went to PC. That's what I was going to. Okay, what I wanted to do is do something like this. Right now we have, the data's coming in, 8, 3, 10, 1, 6, 4, 7, 14, 13. So this would build the tree one at a time. But if I don't start at 8, if I start at 10, if I switch places, this is in a different order, let's make a shorter tree to show this. We have a fairly balanced tree right here. think I wrote down a good set to do that only had a few. Yeah, I'm gonna be doing 6 of them, okay. So 5, 12, 7, we'll do 3, 1, and 20. If we build the tree here, it makes the 5 first. Thank you. Makes the 5 first, 12 comes in, it builds the 12 over here. Then it's 7, 7 is bigger than 5, comes down here, 7 is less than 12, it does this. 3 comes in, 3 is less than 5, so it goes there. 1 comes in, 1 is less than 5, it's less than 3, 1 goes there. 20 comes in, bigger than 5, bigger than 12, gets dropped right here. So a nice balanced tree. What if we had something like this though? 12, 20,
Let's just go.
I don't know, 7, 5, 3, 1. 7, 5, 1, 3. Well, it starts off with the 12. It builds right, it makes the 20. It builds left and makes the 7. It builds left again and makes the 5. It builds left again and makes the 1. And 3 comes in, 3 is still less than 5. The 3 comes down and it has to be to the right of 1. So how deep, this is like too deep. If we call the root 0, this is like 4 deep on the left and only 1 deep on the right. So if you want to be able to make it so that you're like, have like a rebalance option,
You have to reorganize it.
you have to reorganize it, and unless you reorganize it in the right way, like make an array or something, and put the array in the right order and then just populate from the array, it's a pain in the ass. The other option is going, okay, well, I want to make 7 if I want to make 7 the root, let's just make 7 the root, I need to take 12 and make it not the root. I need to move 12 and 20 down here, and now 7 points to 12. This whole thing would have to shift down. Or when you're trying to do different things, having the parent one in there made it fucking awful. Because like that arrow the backwards arrow had to stay intact too. That's going to a null. And like, it was easy changing the root, but like, what if you had like, and I did this, I had a tree of like this, and I wanted to reorganize where like, I think it was lopsided like this. I literally wrote out like 20 numbers by paper and did it. And I said, okay, I want to rebalance it where this is the new root. And using the backwards pointer, it fucking, getting this whole sequence, or even better, making that the new root. Let's make that the new root, not that one. Getting this whole sequence with that to properly line up here with the parent node in there was fucked.
And Reddit had you do that?
I don't know I don't remember if he made us do it or not. I don't know if we had to do the rebalance thing. I wanted to do it because I was trying to learn the code. Like trying to learn how to what I'm doing.
That's crazy.
that's when you're just better off making an array and then making some sort of sort function.
So it's funny you should ask that. Like one of the assignments. Am I on the screen? Yeah, you guys can see it. Your first binary tree is to do what I did, hard code it up. Here is, make sure you know how search trees work and how, like what I just did, drawing the tree with the numbers, that's not what I was gonna show you, but you'll be able to do it. We were doing this, but doing printing in an iterative manner rather than recursive has them using the stack. And so one of your assignments is to do this iteratively. So as you go through the node tree, put it on the stack, and then you can, it gives like pseudocode on how to do it. But back to the code. What else did I want to say? Oh, let's make sure it's actually working for the rest. We have a 14, 10, 14, 13. Or I did 10 up there, so 14. Bam. All right, what else should we do? Okay, so we did the add node function. Don't need that anymore. Oh, let's hijack this. Let's paste it down below. Let's do proper implementation. And get rid of it up here. Shit, there's more to it. MFR. All right, there you go. So things you might do, right now we're having to type mytree.root.report. You might make a print function that does that for you. A print function without having to go to the root. What is, like lab 60 is like, push the envelope a little bit. Oh, make a method that searches for a number. So lab 60 is search for value. Search for a value. So you might try something like, I don't know, node pointer. It returns a node pointer, search val, and take in an integer value here. And so it will return a pointer to the node with the value. Which actually shouldn't be that hard. Well, no. No, not really, because it's kind of like the while thing, the while loop we were just doing. But you're not doing while current equals null pointer, it's, well, you're following down the if left, if right.
You know what would be really difficult? Like every time you inserted another node, that it like, you made it a program so that it kind of balances out every time, so.
Right, that's some serious work. You want to impress me, code that shit up. You should have a delete node, which we did not make. And this one would be kind of easy. Easy, well, I don't know why I had to do that. Either if you have search value already created. Because then you could just say search for value pointer 6, go delete that motherfucker. And right now, both of our, so the way that's, and it should be like a leaf node, not a branch. Now, if you want to go crazy and want to be able to insert or delete in the middle, that's where you bring your A game. You want to show off. You want to show off. Insert node in the middle. Delete node in the middle. 6E is the one where it's like, all right, put this shit all together, make a class. So like code should have at least 5 useful methods. We've got a search value function, one of them. We've got add node, that's kind of cheating because I did that. Print function, delete node. There's several nodes right there. You could do maybe size of tree. That's an option for a method. How big is the tree?
Like how many nodes or what's the depth of them?
Like how many nodes? There's already a what's the depth, find depth. Let's take a look at find depth. My tree dot find depth. How deep is the 6?
I think it doesn't take any parameters, it just kind of finds like the deepest.
Let's go look at it.
Oh, no, it does take it.
Where is this motherfucker?
Second to last one.
Oh, it's really fucking small. No, it isn't, it's really big.
It's recursive as well.
Yeah, it's. It's doing it recursively to find the depth. But it does take in an eye, it takes in a value. What was it doing there?
Is there 6 for the node?
I think it's telling where shit's wrong. 46, I have temp. Really? You want me to comment it out? Line 209. Really?
It just is straight.
It's just, yeah.
It wasn't there earlier, it ran just fine earlier. The fuck happened? Okay, so it found it, but there's no, doesn't see out anything when it finds it, does it? So,
Or do you have to like?
I need to make a little like, see out. Depth, 6. So 6 is at 2, so yeah, the root counts as 0. So that kind of shows how to use it. And the root is the 0 depth. All right, I think that's about it for tonight. Maybe we'll do a search value, or you guys are doing search value. Maybe on Monday night we'll, I don't know, do one or two of these things. Maybe we'll take a shot at inserting node in the middle. We'll see. I've got nothing more for you though for today. Any questions, guys? Bye, Juan. You're welcome. I'll be here tomorrow from 9 to 12, helping math students, but like not very many show up. So if you want to come work on your code and shit in the Mesa Center down below,
I'm pushing people to come. My math class at the same.
other than that, get the fuck out. GTF.